Okay, numbers 13 and 14. You had a calculator, so the first thing to do is get a good sketch of these things. We had some issues with the region. When you're talking about the region enclosed by these three curves, you're talking about this region. It has to be utilizing all three curves to be enclosed. The region down here is not being enclosed at all because it never mentions the x-axis being one of the walls. So for 13, it says we're going to revolve around the line y equals 1. So we need to go denote what we're spinning around. What we notice is this is a disk method because this is totally adjacent from my shaded region to the spinning axis. What I need to do is go in and draw my radius. The radius goes from the curve to the axis of revolution. I'm going to label it. There's only one. That's another reason we know this is the disk method. So when I set up my limits, and again, you're spinning all of these radii all the way across. A lot of us had some issues with the limits. So it's a disk method, so it's pi integral. Now, I start spinning here at -1, and I'm sweeping that spinning disk all the way to 2. Okay, the top curve of my radius is the square root of x plus 2. And now I'm spinning it around the axis of revolution to the top minus the bottom. The bottom is the line y equals 1, quantity squared, dx. When I'm talking about a disk method, I've got pi r squared dx. The radius is the distance between these two curves, top minus bottom. You need to actually draw in your radii so that you can clearly see top minus bottom. We throw that in a calculator. You should get 7/6 pi or 7 pi over 6. Now, question number 14 is spinning around the line x equals 2. It's the same region, but now I'm spinning it around this line, which means that everything is in terms of y because I'm spinning around a vertical line. So my radii is oriented as right minus left. You need to draw in the radii. Now the radii start here. You could have drawn any of these red lines that I'm drawing. Right minus left, everything's in terms of y, which means that my limits are in terms of y. So I start spinning this radius at y is 1. And I stop spinning this radius at y is 2. The curve on the right edge of my radius is the line 2. The curve on the left edge of my radius is my function. Now the function itself is y equals x plus 2 square rooted. So I square both sides, so I got y squared equals x plus 2. So I'm looking at x equals y squared minus 2. So that's the curve I need to use. So right minus left, quantity squared, dy. You should get 53 pi over 15 from your calculator. Right, left. This difference represents the length of the radius. I'm squaring that length. You need to actually draw in this radius. It'll help you identify the right edge of that radius and the left edge of that radius. Okay, both of these are disk methods. Disk methods because there's not any gap between the shaded region and the axis of revolution on either one of these. So it's flush, pi integral r squared d whatever.